so what we're going to talk about today, the objectives is, again, this section is basically, again, exactly the same as the ellipse, okay? We're going to locate the hyperbola's vertices, okay? Again, it's only going to have 2 vertices, okay? As opposed to ellipse, we're going to have 4. Here, we're only going to have 2 vertices, okay? And again, the foci. And the foci are the exact same definition as an ellipse. I'm going to give that in a moment. Okay, and we're going to write the equations of a hyperbola in standard form. You're going to have to graph them, okay? And graphing hyperbolas is a little bit more than just graphing the curve. You're going to have to graph the asymptotes, the oblique asymptotes too, okay? And we want to graph hyperbolas that are not centered at the origin, okay? And finally, we're going to solve very interesting problems with hyperbolas. Very interesting, okay? Especially with sound, okay? Okay, definition of a hyperbola. Okay, if you look at page 616, okay, that first blue box on the bottom, actually in the middle of page 616. Okay, so again, like the ellipse, okay, the definition is very similar. Basically it says the set of all points in a plane such that the difference of the distances to 2 fixed points, foci is constant. Exactly the same. Okay? But it's structured a little bit differently. Okay? So again, if you look at page 616, you can see, okay, exactly the transverse axis, the center, and the 2 vertices. Okay? Or it's called the vertex. Now, there's 2 different forms of the hyperbola. Okay? And it depends. Okay? If one is a function and one is not. Remember function, right? Remember function? For every x, there's only 1 y, right? Or 1 unique y. Okay, so if it opens left and right, this is a function version. It's going to be like this, right? Okay, the formula is simply x squared over a squared minus y squared over b squared equals 1. So note the difference from the ellipse, right? The ellipse has a plus here, hyperbola has a minus. Okay, now, if it opens up and down, the formula is going to be switched, right? You're going to have y squared first. Now, some people write it differently, but this is a way to do it. It's a good way, I think. Okay, y squared over a squared minus x squared over b squared is equal to 1. Okay? All right. So that's your 2 forms. Okay, so if you look at page 617, that blue box in the middle there. Okay, so the first one, again, you can see, right, the a squared is going to represent the transverse axis. It's going to represent where the vertices are. Look at that. Right? 0a, 0 minus a for this, right? Here, a0 minus a0. You see on your book, right? Okay? This is going to give you your vertices right here on that axis. This is on the y-axis, on the x-axis. Okay? So it makes it kind of nice. That's why I think it's a nice form. Okay? Because a is always going to represent, okay, basically the spread of the hyperbola, right? This distance here between hyperbolas is 2a. Okay? Alright, let's have a look. Next page. It's page 618. Okay? So read that for a moment. Now, I will bring this up, again, conic section, again, the same way, okay? I graphed these in Mathematica, so it's kind of nice, right? I actually merged 2 graphs together. So again, this is the conic, this is the cone, okay? 3-dimensional cone. Remember, as I said before, it's x squared plus y squared is equal to z squared, okay? And if you take a plane, okay, and you cut the hyperbola, the cone, slice the end of it, what you end up getting is the resulting graph here is just a hyperbola. And what's also interesting is that this line here will be, as you'll see, will be the asymptotes. And we'll talk about the asymptotes. You're going to have to graph the oblique asymptotes. There's going to be 2 of them this way. It's going to crisscross like this, and the hyperbola will fit into the asymptotes like this, or like this, depending on what the equation is. Now, a parabola will cut the plane like this. Okay, we'll cut it like this. I'm not going to talk about the parabola, but if you took a plane and cut it straight through like this, the resulting curve would be a parabola. Okay, remember, that's why I cut vertically, because the hyperbola has two parts, this part and this part. Or you can do it this way, and like this. Okay, it's kind of interesting. So I think that's kind of the visual is often